Hello, hello. Welcome to week 2 of Lambda School's Introduction to Web Development. My name is Diandra Ryan Moss, and I am back this week to teach you guys some more JavaScript. So it's been, I think, 4 whole days since we last met, so presumably everyone has forgotten everything that we learned last week, but no fears. We're going to start off tonight with a review of everything from last week, from HTML to CSS to JavaScript, and then we're going to jump into a brand new JavaScript topic. Well, not quite brand new. It's functions, and we have talked briefly about functions, but tonight we're going to take a deeper look at them. They are a very critical piece of how to write really great, useful JavaScript code, so it's going to be an important lesson tonight. All right, so before we get into our review and JavaScript functions, let me talk a little bit about Lambda School's main curriculum. So Lambda School is an online computer science and web development immersive. So it is a full-time course where we take a look at all the skills necessary to be a on-the-field web developer. So that's everything from front-end, back-end, to even some computer science topics. Our goal is to get you out the door with the type of skills that you will actually be using on the job. So we are teaching some of the most up-to-date, current, widely used frameworks and tools that are being used out there in the world. So it's a really good way to prepare you for that real-world job. A couple things that make Lambda School special. One is the fact that it is entirely online. And when we say that, we don't mean that it's, something where there's pre-recorded lectures and interactive this and that. It is an actual class. Your lectures are going to be live. It's going to be changing. You're interacting with real other students, with real TAs, with real instructors. So it is all the good stuff of a school where you're actually attending, but you can do it from anywhere. You can do it from your own home. And so that's really cool because it makes Lambda School extremely accessible. If you live in the middle of the desert like me, you can still, well, in my case, I can teach at Lambda School, which is pretty exciting for me. But if you happen to live in the middle of the desert or in North Dakota, not to pick on North Dakota, you can still go to Lambda School. Another cool thing that makes Lambda School special and extra accessible to all types of students is our deferred tuition program. So for most students, there's a deferred tuition program available, which means that you do not have to pay anything upfront. So we push that burden, that risk, onto our own shoulders. So what happens is, to start Lambda School, all you have to do is be accepted. Once you are accepted, you can attend the course without paying a single dollar of tuition. It is only after you are hired that you will have to pay Lambda School back. And I do have to mention the fine print here, which is that this deferred tuition program, some complications can arrive with international students. So if you are an international student, I would reach out to Karen Zachary and find out what tuition options are available to you. If you are domestic, if you're in the United States, then you can most certainly use the deferred tuition program. So a little side note about that. One thing I wanted to talk about a little bit today is the difference between the full-time and the part-time course. So the main program we offer is full-time. That's Monday through Friday during your regular work hours. So you'll be in those hours, you'll have homework time, project time, lecture time, Q&A. So everything that happens between those hours. And that is a 6-month course. Admittedly, it runs slightly over 6 months because of breaks and things like that, but approximately 6 months. Once again, if you're interested in seeing how that schedule looks in more detail based on your start date, reach out to Karen Zachary. So that course starts every single month. So if you're interested in attending the full-time course, it's going to run slightly over 6 months, and a new one starts every single month. So that is our most popular option, but some people choose to attend Lambda School while continuing to work a day job or attend some other day obligations. If that's the case for you, you might be interested in our part-time course. The part-time course runs weekday evenings as well as some time on Saturday as well. So it's Monday through Thursday in the evening with some hours on Saturday. And that takes twice as long. So that doesn't mean twice as much work. It means twice as long, but we're going half as fast. So it's the exact same content in the full-time curriculum. It's just running at a slower pace. So that course starts once every 3 months. So if you're interested in finding out the exact start dates and schedules for that, once again, reach out to Karen. And for all of you guys who don't know, Karen Zachary is our admissions person. So if you are interested in starting the process of getting enrolled in Lambda School, she's also the person to reach out for that. So there's a little insight into our main curriculum. I know a lot of you guys are here because you are planning on attending it or curious about it. For those of you who are just here to learn a little bit about JavaScript, that's totally fine too. On that note, we should get to our actual coding part of the lesson so that we can learn some actual coding. Before I do that, I do want to do a little check-in with you guys and see how much you remember from last week. So we are going to jump into some HTML and CSS before we get started today. Those won't be our focuses for this week, but I want to do a little review. So let's see, let's throw it out there. Can anyone tell me a couple fun facts about HTML? I'm going to make it really open-ended here. Who in the chat window can tell me a little bit about HTML? It is a markup language, great distinction. So versus JavaScript, which is a programming language, HTML is a markup language. Spans, divs, headers, yep, those are all elements inside of HTML. You can place text, images, videos on your web page. It creates the content for your page. It's the structure of a site. All excellent. How about CSS? Who can tell me some fun stuff about CSS? It's the style. It makes things pretty, the dressing. Exactly. Here's a good one. The C in CSS stands for cascading, which means that it is read from the top to the bottom. And yes, you're absolutely right that your websites look really bad without it. As we saw last week, and as we will see when I share my screen, your websites can also look pretty extra bad with CSS too. But you can also make some extremely beautiful sites with CSS. And CSS, just like HTML, is a markup language. So they're a little more straightforward than something like JavaScript, which is a programming language. Well, it sounds like you guys haven't forgotten everything, but let me share my screen so we can look a little bit at the code behind these two languages that we've just talked about. All right. And as a little reminder for the Zoom etiquette for this class, I will be asking questions in chat, and I try to keep an eye on chat throughout the lesson, but if you have any formal questions, make sure you put them in the Q&A section. Occasionally, I'll answer them as we go. The TAs will help answer them, and any questions at the end, I will address at the very end. All right. So over here, we have a web page. Not sure if I've made it beautiful with CSS, but you know, baby steps. So let's take a look first at the HTML. I have some of these elements that you already mentioned here, like divs. This container that houses everything in it is a div. An H2 or header 2 at the top, and a couple of paragraphs down here. So each of these are considered elements. They're the building blocks of web pages. And in order to create them in the HTML language, we start with an opening tag where we put our tag name in brackets. We can put any content, whether it's text or other nested elements inside of it. And then we close out our tag. So the closing tag looks very similar to the opening tag. It just has a slash in it. Excuse me. So that is really the gist of how you write all HTML code. It's all made up of these elements. We create elements using tags. Most elements require an opening and closing tag, though we did see an example of a self-closing tag last week, the image tag. I do not have one of those on page right now. Another thing we might do with HTML is add IDs and classes in. IDs and classes are attributes. They're kind of little extra bits of information we can add to our elements. And IDs and classes are specifically used for styling. So because I've added this child class to 2 of my paragraphs, what I'm saying is that I might want to style these 2 paragraphs in a uniform way. I might want a style that applies to my first paragraph and second paragraph and nothing else. My ID is also a way of potentially styling this div. And just a reminder of the difference between an ID and a class. IDs are unique, so only one element can have this parent ID. I couldn't plop it on anything else, whereas classes are unlimited. As many things as I wanted to put the child class on, I would be welcome to do that. So let's move on over to the CSS. CSS code, as you guys mentioned, is the styling of the page. And CSS code is made up of 3 components. We start off with a selector. We select an element. And just a little reminder, the body element, even though I haven't actually written it on here, because when we're working with CodePen, we can skip it, the body element is basically just the background. So to get a background color, I had to select the body. So this selector says, let's style the body, let's style that div, let's style the H2, the header, let's style everything with this class name and everything with this ID name. So within our selector, we have a couple of brackets, kind of similar to JavaScript. You guys have seen the curly brackets used in JavaScript now. We start out with the property that we actually want to style, in this case, background color, and the value we'd like to set it to. So we can put these property value pairs inside of the brackets with each selector to style each of our elements or whatever else we've selected. So there's only one style for the body, but there are 4 styles on my div. Speaking of the styles on my div, can anybody tell me what's going on here? I have this command down here, this bit of code that says that the background color of my div should be green. But as we can see, the background color is not green. Can anyone take a guess, or maybe you noticed when I scrolled down, why this is happening? Yep, that code is being overwritten somewhere below. And if we look down, we can actually see where that's happening. So this is where CSS gets really interesting, is that oftentimes there are many competing styles. And we have to use a concept called specificity to figure out which style is going to win. In the case of a real world application or website, this can get extremely complicated. Specificity is no joke. But in this little web page, it's pretty straightforward. The ID selector, which notice we use a hashtag to select IDs, is going to be our most specific. In other words, this style is going to win. The next most specific is going to be our class. See, we've used this class to make those first 2 paragraphs larger than the other ones. And then after that is going to be all of our element selectors. So there is a hierarchy in which styles matter. As mentioned, this hierarchy is only the beginning of the topic of specificity, but it's a good place to start. So there's a little reminder of how CSS works. Finally, I want to talk a little bit about how JavaScript plays into this puzzle. Unfortunately, in this intro class, we won't be doing a lot of actual JavaScript within a web page. That's because in order to get to the point where you're ready to start changing or working with your web page in terms of JavaScript, you have to build up a bunch of fundamentals. So even though we won't be actually manipulating web pages in this intro course, we're learning all of the skills necessary to get there. And of course, you'll be doing tons of that in the main curriculum. But I did talk a little bit about how JavaScript plays into this puzzle. So can anyone tell me what JavaScript's role is in terms of web development? When you're adding JavaScript to a web page, what kind of things might you be accomplishing? Making the page interactive. Someone mentioned the DOM. That's a really good little vocab word. So DOM is the document object model. That is how we use JavaScript to affect a web page. So it's the magic. It adds functionality. Buttons. I like buttons because that's a tricky one. So we use HTML to add a button on the page. I could literally add a button right now. There it is. But nothing happens when I click it. So HTML creates buttons. JavaScript is what makes the buttons interesting. It's what makes it so that something happens when we click our buttons. So yeah, buttons, dynamic content, things that change. Data. Data is a big one. the flow of data, the fact that you're able to store something, to create a new Facebook post, to create a user account, to store your credit card on Amazon. There's a lot of logic that has to go into you being able to safely store your credit card information online. That's all happening behind the scenes with JavaScript. A little preview of some of the stuff we might do. So there is a object called document in JavaScript. It's a built-in object, kind of like the console or math. And it's what we use to actually add JavaScript to our web pages. So what we can do, and I'm not going to get into the weeds of this. I just want to give you a little taste of some of the things we can do with JavaScript. So in this case, I've used a method here to actually find the first paragraph on my page, and I've stored it into a variable called p. So here's a little preview of our JavaScript review that's to come. Can anyone tell me, based on just what I just described and what you know, does this line of code have any side effects? Anyone remember this annoying side effect thing? And don't just give me a yes or no. Tell me, if you say yes, what side effect does this have? So if you think this line of code has any side effects, declaring a variable. Exactly. So specifically, we're actually storing a value in memory somewhere. In this case, we're storing the address to one of our actual HTML paragraphs. So before we were storing some pretty simple things like strings and numbers, but now we're actually storing an HTML element in memory. And now that we've done that, we can change it. So we can do crazy things like this. Oops. All right. Can anyone tell me, did line 2 have a side effect? And what side effect was that? Yep, it changed the color. So in this case, we actually saw that side effect. So it literally changed the color on our web page. And so this is a pretty simple example of what we could do with JavaScript, but just a little taste of how whatever we started with here, whatever our starting style or our starting elements are, those are subject to change. Because now that we're in the JavaScript tab, it's like the Wild West in here. We can do whatever we want. I'm thinking of the Wild West because I've been rewatching Westworld, which is a fantastic show, by the way. Totally, I mean, not totally unrelated to this. It makes me wish that I could program crazy, intelligent, sentient robots, but you know, one step at a time. You start with basic JavaScript, next thing you know, you're creating sentience. But anyways, so totally unrelated. Maybe we'll have a Wild West themed lesson tonight. So this is just an example of how you can start to change whatever you want on the page once you work in JavaScript. But before we can actually do fun stuff like that, we have to get a little more comfortable with the JavaScript language. So let me switch over to Replit. Oh, I forgot to clear it. A little reminder of what we were doing last Thursday. Let's do a little more of a JS review, and then we will talk about functions for the rest of the night. Okay, so I am actually going to start with my 2 favorite keywords, side effects versus code resolution. Not mutually exclusive, but different concepts. So can anyone, we've talked a little bit about side effects already. Can anyone define a code side effect for me? Or throw out some examples. 2 examples we've already seen are a color changing on a web page or something being stored in memory. And yeah, and I really like this very simple but very to the point description of a side effect. Something changes, anything changes. So a file changes, something changes in memory, an email is sent, you steal $40,000 from someone's bank account, all side effects that might be accomplished with code. And in fact, on a actual script, every single line should have a side effect. Sometimes we type out lines that don't have a side effect in this intro course. Like I might type out just a string, just to remind you guys what a string is. But when you actually have a finalized script, every line should have a side effect. If it doesn't, it's useless. What's it doing there? So really, you want to be working towards the point where every line of code has a side effect. So if you have something like this in your code or something like this, you should probably think about what it's supposed to be doing and what it's really doing, because neither of those lines have side effects. So our goal really is to get to the point where every single line of code has a side effect, and we as the developer know what the side effect or side effects are. So side effects are quite important. And as mentioned, some of the code we might put on screen in this intro course might not have side effects, because I'm just trying to illustrate a point to you guys. Can anyone define code resolution for me? Yep, so I feel like you guys maybe aren't quite getting to the essence, but you're getting close. So this idea of something is returned, something is computed. Ooh, here's one I really like, the digestion of the code. So it's that, I like that a lot. I might use that word in the future. So it's this idea of when the code all comes together, what trickles out at the end. So obviously 1 resolves to 1. It just is a 1. But if we have 1 plus 2, once we've digested that statement, it becomes a 3. Once we digest something like math.round 1.2 plus 10, this digests down to 1, so this whole thing digests down to 11. And code resolution is really important because it's this idea that different chunks of code can build upon each other. So anything that resolves to something can be part of a larger statement that does something else. So math.round, because it resolves to 1, could be used in a larger statement to replace the number 1. And yeah, I in fact see another person in chat saying it can be interchanged. That's another good way to think about it. So if I want to create a variable called 1 that's set equal to 1, there are a million different ways I could do this. I could assign it to 1, but I could assign it to anything that resolves to 1. It could be 1 plus 10 minus 10. That resolves to 1. We already saw math.round. Anything that rounds to 1 would work. We could do, how else could we create a 1? I mean, I don't know, we could do 4 minus 3. Anything that could create a 1 can go in here. So anything that resolves to 1 is replaceable in there. So that's the idea of code resolution. So we always want to know, what does our line of code, what side effect does it have? And it really should have a side effect if it's there. And what do different chunks of our code resolve to? And with the resolution thing, we can actually talk about chunks. Now, not every line of code resolves to something. For example, when we actually declare that variable, this whole line doesn't resolve to anything. That means it can't be exchanged. It can't be interchanged for something. It does have a side effect, though, which is that we create a new variable. And ooh, I like that one. Here's another way. I did not teach you guys the mod operator, but I believe either in the homework last night or maybe tonight, not last night, Thursday, that you guys might have had to research the mod operator on your own. I personally am a big fan of the mod operator because I am a math nerd, so I could do modular arithmetic all day, but once again, that is beside the point. Cool. So these two terms are, many people can program for years without really understanding how these work. So on one hand, don't be too hard on yourself if you don't fully get them. On the other hand, there is a reason I brought them up on day 1. And that's because I want you guys to be excellent programmers. I'm kind of a snob. So my goal is to not just teach you how to do stuff, but to teach you what's really going on and how it works. And mastering these two concepts is mastering JavaScript. So that's why I keep harping on them. All right, so a few more practical things in JavaScript. We already mentioned declaring variables. If we want to declare something constant, like I am a snob and I will always be a snob, so we could turn that to set isSnob equal to true. And because that's a constant variable, this variable name is bound to this value. So these are tied together. This will always be set to true, at least as long as my script runs. However, for some values, we might want it to change. So for example, I'm a little hungry right now. So we could set hungry equal to true, but after class, when I make myself a quesadilla, hungry will become false. So I'm able to actually change the value of hungry. At this moment on line 4, hungry was tied to the value true. But by the time we hit line 5, hungry now became set to false. These are the 2 ways I want you guys to declare variables. There's also var. I don't want you to use it. Once again, it's a snobbery thing, but it will also make you a better programmer. So every time you declare a variable, ask yourself, should this value change or should it be bound together? And use const or let depending. And notice that when we reassign a variable, we don't need to redeclare it. We only have to declare a variable once, and then we can just keep reassigning it, such as we've done on line 5. A couple other things I want to review with you guys are if-else statements. We talked about control flow. Can anyone quickly tell me what an if-else statement is in chat? I might start to type one out as you guys do that. It's a choice, exactly. It's a choice in the code. It's a branch. So sometimes you might want the code to do one thing in some cases and something else in another case. So if we are trying to create an automated JavaScript teacher, it might say something different depending on if it is a snob or not. So if it's not a snob, it might say that using the keyword var is all right. And the structure of an if-else statement is we have the keyword if followed by some sort of condition. Usually this is going to be a Boolean, but even if it's not a Boolean, based on our truthy and falsy values, it will still work. So, and it will separate the code out into 2 blocks. The first block is all the code we want to run if this is true. The second block, followed by the keyword else, is all the code we want to run if it is false. So we will always have either all of the code in here run or all of the code in here run. One of each choice. We can never have both, and we can never have neither. And the reason I'm saying all of the code is because even though in this and most of the examples we've seen so far, there's just one line in here, we could have 300 lines of code that only ran if isSnob is set equal to true. So in another example of control flow that we learned last week is the looping. Looping is a little different. Whereas if-else's create a choice for the program, looping creates, well, a loop. When we want the same line of code or very similar lines of code with slight changes to run over and over and over again, that's when we might use a loop. There are a few different loops inside of the JavaScript language, and honestly, these loops tend to be pretty much the same across all programming languages. One second, let me write this out. So the one loop that we talked about is the for loop. The other loops are, there's a while and a do while, kind of useless, honestly. They exist, but they're kind of useless, which is why we don't teach them, or at least we don't teach them in the intro course. There is one more loop, which is my absolute favorite loop, and we will learn that on Friday night. So I know it sucks to have class on a Friday night, but here's a little incentive. You guys get to learn my favorite loop if you come on Friday. And you're absolutely right, Gustavo, it is a for each loop that we will be learning on Friday. So let's talk about the for loop though. So the for loop has 3 parameters. We have a starting point, a stop condition, and a change. So essentially we have this value called I that's keeping track of where we are in our loop. We're gonna start it somewhere, usually at 0, and then we will keep it going until it fails some criteria. In this case, we want it to keep going as long as I is less than 10. And in order to prevent an infinite loop, we need to be changing I in some way. So the most common way to do that is I++, just increasing I by 1 every time. In that way, we can write a simple piece of code that maybe logs 10 numbers. If we wanted to log 100 numbers instead of 10, all we would have to do is add a 0. So it's a very useful dynamic way to repeat ourselves. And loops are useful for more than just logging out numbers. We can do all sorts of interesting things with I. Some examples where we might use a loop. If we wanted to go through a set of users and generate something for each of them, we could loop through them using I to grab an index of each of our users. If we were pulling values from an Excel spreadsheet, we might loop through and that would tell us which row we were pulling data from. There's all sorts of scenarios where we might be looping. So very useful tool to have. The last thing I wanted to mention just briefly is debugging. We haven't explicitly talked about debugging yet, but it's actually probably the most important thing that you need to do in the programming world, except for Googling things, which, by the way, whenever you don't know something, look it up online. Yay, documentation. So I did want to talk to you guys a little bit about debugging. You've had some experience with this with the homework, I would guess. So you might have been kind of playing around, learning your own stuff, but I wanted to just give you a few tips. The first tip is that whenever you're running your homework, here's a little, oops, I accidentally closed out my screen share. Let's put that back. There we go. So whenever you're working with your homework, always press run first to see if there are any errors. Errors can be kind of scary when you're not used to them, but it turns out they're mostly your friends. They will help you figure out what is wrong with your code. So if you just have if you're trying to just run something and you press run and you get, for example, a reference error, first of all, always check the line. So there will be a little message here that tells you where to look for your error. So I would know, okay, I need to go to line 8. Something is wrong with this line. And if I'm not sure what, I can go back and see reference error. That's a really common error. That occurs when you try to use a word that is not a keyword and not a global object and has not been declared. Turns out that add has not been declared anywhere, so that is why we're getting this bug. So make sure that you're looking for, you're playing around and seeing if there are any errors on your homework and checking the lines that they seem to be coming from. If there are errors, your test will go totally haywire. Another common thing that you might deal with is if you're doing a bunch of logic, and something's not panning out and you're not sure what's going wrong, you might want to, oops, const. You might be curious. You're like, okay, somewhere something is going wrong in this logic. It's not running an error, but something's going wrong. Use console log. Console log is a great debugging tool. So if you're curious, you're like, I think y should be set equal to 9, but I'm not positive. Let's say that you run this code. You can see, okay, y is what I think it is. If instead you said, okay, I think that y should be set equal to 4, right? Because we did x plus plus, we could run this and see, no, I thought y was going to be 4, but it's actually 3. And I won't get into why this is in this case. But the biggest takeaway I want you guys to have is that if you're stuck, if some bit of code is not doing what you expect, throw a bunch of console logs in. Make sure that this line might seem obvious to you, but it might not be doing what you think. So the 2 biggest pieces of advice I have for debugging your homework is, first of all, check if there are any errors. That's like low-hanging fruit. Second of all, throw in a bunch of console logs. They will help you see what's really going on. So just something we didn't really talk about last week, but is a great tool to have in your tool belt, is a few debugging skills. All right, well, we're about halfway through our lecture and all we've done is review, which is okay because we're back after a long weekend. But let's go ahead and move on to our new topic tonight, which is functions. So I guess I just said we were done reviewing, but I will spend just a brief moment going over some of the functions we've already seen, and then we'll dive a little deeper into functions. So a few of the functions all the functions we've seen are methods. So methods are a type of function. So functions are just a JavaScript type, just like strings are a type or Booleans. Functions are another type in JavaScript. They're a little more complicated, but they're still a type. And methods are a subcategory. I'll call that subcategory of functions. So some methods that we've seen, we've already played a little bit with math.round. That is a method that you put in a number and it pops out the rounded version. There are some other variations such as ceiling and floor, which round down or up every single time. We've also played with math.random, one of my favorites. It creates a random number between 0 and 1. Console log, yet another example of a method. It makes something appear on the console. As a reminder, the console is a little hidden sidebar in your browser. In Replit, it is mimicked in this section in white. So remember, this isn't really the console over here because we're in a sandbox environment. The console actually exists over here. This is the actual console. We can see some console messages from Replit itself, but we can't see our own console logs in Replit because it's a sandbox environment. So console log, that is another example of a method. There are also methods built into different types. One example is strings. Strings have lots of methods. So if we had a string called name, we could run to uppercase. That's kind of, to uppercase has kind of become my go-to method that I like to show. We could even do to lowercase. And that's just a couple examples. There are tons of interesting things we could do with the strings using different methods. So let me define method. Methods are functions built onto some object. So what exactly does that mean? Well, unfortunately, we might not be able to fully unpack that definition until Thursday. I'm like, Wednesday. No, we're shifted by a day. We will be able to fully understand what that definition means a little more tomorrow and definitely by Thursday. But from a very loose standpoint, we could just say we know it's a method if there is something dot the name of our method. That's how we know it's a method. It's built onto something else. To lowercase is built onto our string. Random is built onto the math object. Log is built onto the console object. So that is how you tell a method. Something else that's important about methods and actually pertains to all functions is this set of parentheses. Can anyone tell me? I'll even throw out a few different methods here. We have console log. I'll throw math.random down. All of these methods have parentheses. So can anyone tell me why that pair of parentheses is important? What is it doing? So there's this idea of something needs to be passed through. It's actually not necessary that something be passed through. In some cases, we do need to pass values into them. But notice in the case of random or lowercase, we actually don't, and they still work. But you guys are absolutely right that it runs the method, it executes it. So what do I mean by run the method? Well, I'm going to pull out my absolute favorite metaphor for functions, which is functions are like recipes. So imagine I mentioned making quesadillas later so that I can set my hungry variable to false. Let's say I have a recipe for quesadillas. So I have a piece of paper that says ingredients, and I have a bunch of ingredients listed, and then I have steps, and there are a bunch of steps listed. So if I have this sheet of paper in front of me that tells me how to make a quesadilla, do I actually have a quesadilla yet? It's kind of an obvious question. No, I do not. And I know that seems so ridiculously obvious, but I want you guys to think about that when you're thinking about functions. So if I have just math.random without the parentheses, this is like a recipe. So do I, just by running, I'll get rid of the rest of this, just by running this line of code, do I have a random number yet? No. All I have are the instructions for how to get a random number. And they're kind of hidden behind the scenes. But think of math.random without the parentheses as being a set of instructions for how to get a random number. If we run it, it'll just say function random. So once again, they're kind of hidden, but we could think of this as a set of instructions. If I have console.log, will anything appear on the console? No. We just have the instructions for how to get something to appear on the console. If I do name dot to uppercase, I think you guys are starting to get the picture. We will not have Jimmy in all caps. We just have a set of instructions for how to do that. So these parentheses, above all else, that's like where we actually make the recipe. So that's where we execute the function. So think of executing a function or running a function as like making a recipe. We're taking an instruction and we're turning it into a real thing. So this, now we actually have Jimmy in all caps versus just having something that says function to uppercase. As far as the ingredients go, this is where the metaphor breaks down slightly, because when it comes to recipes, the ingredients are not optional. I personally, maybe I'm missing out, but I don't know of any recipe that you can make without ingredients. It turns out that in JavaScript, you can run a function without the ingredients, like math.random. This is an ingredientsless recipe. We can get the result without putting anything into it. But some functions require ingredients. They require things to be put inside of the parentheses. Can anyone tell me a method that we've seen so far that requires ingredients, that requires input? We've seen a few of them. We've seen some already tonight. Yep, console.log. If we run it, even though we've run it, nothing appeared on the console, kind of a blank line appeared on the console. So we need to make sure we put something in. So this ingredients idea is called the arguments. Parameters is a better term for the ingredients. We will talk about the difference between these two terms in just a minute. So the two terms for the input or the ingredients of a function are going to be parameters and arguments. A little preview to the difference between those. Let's actually look at math.round. So math.round expects a number. So we would say the parameter is a number, one number. That's what we want to put in. In this case, the argument is 4, which is not a very interesting argument if we're rounding. If we did, so on line 9, the argument is 4.99. On line 10, the argument is 1.1. So the arguments can change every time we run it. So you could think of it as this. The parameters are like the actual ingredient. You know, it might say 2 apples. I don't know why we're putting apples in quesadillas, but so let's come up with something more quesadilla-y. So 1 bell pepper. So on the recipe, it might say 1 bell pepper, or, you know, shredded chicken, or Mexican cheese. Yeah, I'm really getting hungry now. So that would be our parameters. But I'm going to go to the store and pick out a specific bell pepper. And that is the specific bell pepper that I will put in my specific quesadilla. And you might be reading the same recipe in North Dakota, but you are going to the store and buying a different bell pepper. So that is the difference between parameters and arguments. Parameters are like the idea of the bell pepper, whereas the arguments are the specific bell pepper that I have in my hand versus you have in your hand. And a smoked brisket apple salsa quesadilla sounds fantastic. I used to live in Texas, so I've been craving brisket for like a full year now. All right. So, okay. So that's the difference between parameters and arguments. They both refer to input though, and we'll explore that more when we start writing our own customized functions in just a minute. The very last bit of terminology that we really need. So input, arguments, slash parameters, and output. Does anyone remember what the output, there's a word that we use to refer to the output of a function. Does anyone remember what that word is? And this is very similar to the idea of code resolution, return value. So whatever a function resolves to is called the return value. So we know that math.round returns out a number, in this case, the number 1. This math.round returns out the number 5. Here's a question. Do functions always have return values? No, that's absolutely right. So some functions might have a side effect, but no return value. Here's an even tougher question. Can anyone tell me a function that we've worked with that does not have a return value? Console log, yay. Console log's tricky, right? Because we think, well, it does something. Remember, it's a side effect. This 4 appearing here is a side effect produced by console.log. So a console log statement would be seen on its own. This is a totally useful line of code. Math.random, just on its own, is totally useless. It's returning something, but we're not doing anything with it. If we stored it in a variable, like so, now this line of code becomes useful again. So we want to make sure that if our function doesn't have a side effect, that we're storing its return value somewhere, or else what was the point of even calling it? So there's the rundown of functions and how they work. But things get really interesting when we start to write our own functions. So let's go ahead and do that. So this is like we're now writing our own recipe. Okay, so if we are writing our own recipe, what's the first step? What's the first thing we want to write out for someone who might be using our recipe? Any guesses? The ingredients, yay. Okay, so the ingredients, in this case, the parameters. So what kinds of parameters do you think an add function should have? So this add function is going to be really simple. It's just going to add some numbers together. Yep, so we definitely want some numbers. And in fact, we could have this be something that adds a bunch of numbers together. I'm just going to have it add 2 numbers together. I'm going to call them x and y. So this is where things get abstract because we don't know what numbers x and y refer to. And they're going to refer to different numbers as different people run our function. But we can still add them up. So this is like our ingredients list, and these are like our instructions. Which are actually called parameters. I'll put the non-official term in parentheses. I once had a tutoring client. I used to do private tutoring, and I once had a tutoring client tell me that she was never sure what were technical terms versus the terms that I just made up because I thought they were useful. So I always have to be mindful of that. So here we go. And so x and y. And actually, I really like a point that was just made, which is that we've intended these to be numbers, but they don't actually have to be numbers. And we'll play with that in just a minute. So we have our parameters, we have our instructions. Is there anything we're missing? We've gotten the numbers, we've added them up. Surely we're done with our function. There couldn't be, oh, a return value. I will tell you right now, most of you will forget at least one return value on your homework tonight. You will be slamming your head against the wall, hopefully not literally, trying to figure out why your function isn't working. Check for a return value. Console.log, x plus y. isn't going to work. I mean, it will make something appear on the console, but your function should return something. So make sure you use the keyword return to return out whatever value you want. And because of code resolution, whatever x and y, x plus y resolves to will be returned out. So we have just written our own function. The syntax is we use the function keyword, we name our function, we list our parameters in parentheses. This is very similar to creating variable names. We just come up with useful names that might refer to the types of things we want to see be put into our function. We have a pair of brackets, and then we return whatever result we want to. So if we want to test out this function, we can call it just like any normal function. So what happens if I just write out the word add over here on line 12? What's going to happen when I run this code? Not quite an error, because we have defined add with the function keyword. But nothing very interesting will happen, because this, once again, this is like we just have a recipe in front of us. We have not made the recipe. What do we need to actually execute our function? Parentheses. So we need parentheses to execute. And we need ingredients. We need to put our x and y inside here. So I'll do 4 and 5. All right, so in these cases, what are the parameters and what are the arguments for this kind of whole example right here? Which one are the parameters and which ones are the arguments? They both refer to the input. So the arguments are up here. X and Y are, or sorry, our parameters are up here. Even I like to mix them up all the time. X and Y are the parameters, 4 and 5 are the arguments. X and Y will always be the parameters, but the arguments can change. And as someone mentioned, we don't even have to put numbers in. If we tried putting strings, the code would do something slightly different. It would use the add operator as it pertains to strings. We could add some error checking in here and check our type of X and our type of Y and make it crash if we didn't put numbers in, but we're not going to get that fancy tonight. So there we go. We've created an add function and we have actually called it. So yep, and if we put strings inside of this, it will concatenate them because the plus operator means something different for numbers versus strings. Concatenating just means smashing them together. So there is one other way we can, actually there are a few other ways we can create a function, but I'm going to show you one more. So I'll comment this out real quick and show you one other set of syntax for creating a function. So this does almost exactly the same thing as the code I just commented out, but the syntax is slightly different. So this, what I've just highlighted, is called an anonymous function. It looks, actually, I'm going to comment it back in just so we can see it really clearly. An anonymous function looks exactly the same as this function declaration, just minus the name. And anonymous functions are useful in a few different contexts. We'll see them a few more times this week. One thing we can do with an anonymous function, one thing we cannot do with an anonymous function is just have it hanging out on its own. It's like an unaccompanied child. We don't want it just wandering around on its own. So this does not work. But there are a few different places we can use anonymous functions. And one is that we can actually store them into a variable name and use const or let to declare our variable. So this is just another way of creating the same thing. So these lines of code do almost exactly the same. One difference between them is this style has a little nifty feature where you can actually call add above where you declare it. That's a little extra feature of declaring functions in this way. It doesn't work if you do the anonymous function and assign it into a variable. So, but for the most part, I would just say think of them at least now as being the same and practice writing functions both ways. Let me get back that other one. So you can either declare it with a keyword function or create an anonymous function and then store it into a variable. You can't have both because you're trying to assign the same variable name twice, but you can do one or the other. So let's play with a couple other functions that we might do. I'm going to create one called sayName. All right, so here's my sayName function. So here is a new function that, similar in some ways to our last one, a little different. Can anyone tell me what the parameters are for this function? What are the parameters, if any, for my sayName function? The name. Yep, so it's just expecting one string. And it is expecting a name, but we could put anything in. It'd be less interesting. It wouldn't work as well, but what about the return value? What's the return value of this function? It's a trick question. There's no return. And we can always tell if there's no return because of the keyword return. If there's no keyword return, there's no return. So this function does not have a return value. It does have a side effect though, so it's not useless. We could create a completely useless function just by doing this. So now we've created a function that has no return value and no side effect. Not a very interesting function. We could create a version of this function that returns instead of console logs. Notice that it appeared in the console in white. Now it just, oops, let's put a space in there. Now it just returns the greeting instead. So it's actually really simple to tell if something has a return value or not, as long as we can see inside it, because the keyword return will be there. So there you go, another example of the kind of function we might write. Some other things I want to talk about are, let's see, I want to talk about scope. Do you guys remember scope? Scope, my rule of thumb for scope is if we have a pair of curly brackets, we're probably creating scope. So on the subject of scope, can anyone guess what's going to happen if I try to access the variable name out here? Any guesses as to what will happen when I run this code? An error, absolutely. Actually, that's weird. I think I defined it earlier. Let's use something else. Let's call this first name. Replit likes to remember variables that we used in the past. Let's try it now. There we go. That's what I expected. A reference error. First name is not defined. Why is first name not defined? Why I was able to use first name on line 7. Why wasn't I allowed to use first name on line 10? What's going on? Outside scope, outside of the box. Great answers, guys. So these names or these parameters only exist inside of the function scope. They only exist inside the function scope. What if I create a variable called greeting? And then maybe I returned greeting. What's going to happen if I try to access my greeting down here in the global scope? Remember, the global scope is just anything outside of any brackets. So we're going to get the same thing, the same issue, reference error. So any parameters and any variables declared inside the scope are only available in the function. Nice little memory clue for the scope is what happens in Vegas stays in Vegas. What happens inside the scope stays inside the scope. Anything created, so it's specifically anything created inside of the scope declared is only going to be accessible in the scope. There are a few other scope-related rules going on here, such as that the return keyword is scope specific. If I try to use the return keyword outside of a function scope, I'm going to also have some problems. Speaking of return and scope, scope actually gives us some insight into why the return keyword is so important. So up here on line 7, let me scoot this out. On line 7, we created our greeting, but it's stuck inside the function. There's no way, it's like in a fishbowl. There's no way to get out. So the return keyword is key. It's the only way of taking a value inside the scope and returning it out to the global scope. It's like a scope whisperer. It's like a scope ambassador. It will relay a message from one scope to the other. So the return keyword is really important for a lot of reasons, but especially because of this scope stuff. So yeah, so that is how scope plays into this. We'll keep talking a little bit about scope this week. Once again, a topic you don't need to master, but a good thing to start thinking about now. The last thing I want to talk about before we go over the homework and I do questions is these return values. There's a few other things that, or a few subtleties with the return statements that you guys might not realize. So I want to go over them. So let's see. What do you guys think is going to happen? Oops. When I call say name. Any guesses of what's going to happen? Can you tell me everything that will happen over here when I run this code? So we're going to get a greeting, and we have this return and this console log. So, and I see that you guys actually aren't sure what's going to happen here. That's good. We're exploring. There's no console log. Why? So the console log didn't happen. We got a return value, but no console log. Why didn't the console log happen? I'll give you a hint. If we move the console log up one line, it will happen. And that's because we stop, as some of you guys already seem to know this, we stop at the return. Okay, so what happens if I run this? I have now 2 return statements. First, we're returning the greeting. Second, we're returning the word potato. Only the first will run. So it's actually pretty straightforward. It can seem mysterious at first, but it's pretty straightforward. Everything that happens after the first return is ignored. It's straight up ignored. So return acts as it not only spits a value back up, it also says we are done with this function. We don't care what else happens. It completely stops us. What happens if here's another interesting one. What's going to happen when I run this line of code? Or this whole thing? Actually, the same thing. The console log is never run. It turns out we just need the keyword return. It doesn't matter what comes after return. Once return hits, it's like a period at the end of the sentence. We are done. Nothing will happen afterwards. So here's a question for you guys. Can a function ever have more than one return value? Can a function ever return more than one thing? No. So there's only ever one. Sometimes there's no return value or an undefined return, but it can never have more than one return value. Here's a subtle distinction. Can a function ever have more than one return statement in it? Useful return statement. Obviously, we can put as many as we want. So the answer is yes. And the reason is, someone got it with branching. So we might say, if greeting, then we want to return else. Maybe we want to return So why am I allowed to have two return statements? And this is a well-written function. Can anyone explain to me why I'm allowed to have two return statements in this code? But in that last example, it kind of made things weird when I had two return statements. Because only one will ever be run. In some cases, and we could even, if else statements get a lot more interesting when we pass it in. So now we would say name. Now this if else can actually respond to a Boolean we're passing in. If we change this to false, it will say goodbye. So a different return statement will be run depending on if this is true or false. So sometimes we'll have multiple return statements, but we can never have more than one return value. And if we ever leave off the return, that just means it returns undefined, or we could just say it doesn't return anything. So another little insight. And the final thing I want to mention here with this example is notice that I have put an if statement inside of my function. And that's totally allowed. I can have an if statement in a function. I can have a loop in a function. And you will, in fact, see some of those tonight in the homework or have to create them in the homework. Just make sure that you're tabbing everything in. So it's clear that we have the function, which contains the if statement, which contains the if block and the else block. These tabs are really important. They won't crash your code, but they will render your code very difficult to read by yourself and others. So you will have to be doing stuff like this on the homework, putting some of these other tools we've learned inside of functions. Speaking of the homework, let's go over that. So what we have done is we have defined out all of the functions for you, and you have to fill in the steps. So we've named the function, we've listed our parameters. You guys just have to actually define out the function. So important thing, once again, this happens, a really common question I get on the homework is, okay, we're supposed to add one, why isn't this working? It's because you have no return statement. If it says in the description returns, there better be a return statement in here or something is broken. So all you have to do is fill in the gaps and run the tests, and we can see it's already passing. So you do not have to call this if you don't want. However, if you're trying to debug it, it might be useful to call your function and pass it in a console log, press run, and then you'll be able to see if it's working or not. So once again, if you try this and you're wondering why your test is failing, you might see, okay, well, I thought I was adding one, but I'm getting a 4 return from a value of 4 passed in, so something's broken. So that's a little bit of a clue of how to work on this homework. You don't have to call your functions, but you might want to if you're trying to debug them. So let's just go through. We have a divide function, a get biggest. You're going to have to do some comparing here. To get the length off a string, pizza related question, countdown. I should go in and change them all to quesadilla related questions. Countdown, that's going to require a loop. Repeat also will require a loop. And this last assignment, I just want to talk to you guys about very briefly. So at the beginning of class, I mentioned that we won't be doing any true DOM manipulation in this class. That just means we won't be writing JavaScript that actually changes a website. But to get you starting to think about that type of thing, I have included throughout the rest of this week some questions that relate to HTML. So this is just saying, take in a string that represents a tag name and return a string that looks like an opening and closing tag. Don't overcomplicate this question. You don't need the document. If you're typing out the document, you don't need it. It's just string manipulation. It's forcing you to start to think about how you might use JavaScript strings to create something that looks like HTML code, but it's still just JavaScript. So just play with strings and you'll be fine on this question. So that is the homework for tonight. Let me answer a few questions and then I will let you guys go. And in fact, I already see a question that's been floating there that I've been wanting to answer. So if we have a function, remember this is this other style of declaring functions where we create an anonymous function and we save it into a declared variable. And our question is, can I show you guys how to call this? Yep, it's actually exactly the same. No matter how you declare it, you call the function in exactly the same way. You just take the name, follow it by parentheses, and pass in any arguments you need. And it will work just the same. Cool, so how does a return work with loops? So if you had, I'll first show you what not to do. Actually, let me go over to the homework. Notice that the looping question says logs a phrase. There is no return value. And countdown says logs numbers. There is no return value. So generally speaking, you do not want to put a return value in a loop. It won't work very well. If you try to do something like this, oops. And let's return I. Can anyone tell me what will happen when I run this function? A little review of how returns work. What is going to happen when I run this function? It's not an infinite loop. We've set it up in a way where it will definitely quit once I gets to 10. It will run only once. Yep, so it'll return 0. Because remember, the first time we see our return statement, we're done. So if you ever have a return in a loop, you can be pretty sure it will not actually loop past the first iteration. So once again, I think that's something that every programmer has thrown a return statement in a loop and then been thrown for a loop for why it's not working. This is why it's not working. So watch out for that. Question about where to locate the recording for this session. So it takes a minute for it to get up. I send it to a TA named Alan High. I hope I'm saying his last name correctly. So if you're looking for it later tonight or tomorrow, just hassle him or hassle me and I'll hassle him for you. If you desperately need a recording, you can always reach out to me and I can actually send you the file. It's just really big. So usually it's better to wait for it to go up onto YouTube. So I'll send this to him right when we're done tonight and he will have it uploaded as soon as he can. Any other questions? Where is Thursday's class? Excellent question. I will hassle Alan about that and see if I can get it to you guys. Otherwise, if I can't get a hold of him, I'll just post an actual copy of it in Slack so you guys have it. Well, you guys are being pretty quiet on the question front, so I will take that as a cue for me to stop talking and let you guys work on this homework. All right, so good luck with the homework. It is on Replit, so as long as you have access to Replit, you'll be able to access the homework. If anyone does not have Replit access, reach out to Chris Schroeder and he can get you that. There is no link to it, unfortunately. So yeah, that's it for tonight. We'll be working on functions tonight, and then tomorrow we'll talk all about data structures. Actually, speaking of multiple return values, something like an array or an object, which we'll explore tomorrow, is kind of the workaround if you want multiple return values. So we'll play with that tomorrow, and until then, good luck with the homework. I'll see you guys then.